M16 rifles. What that meant was the U.S. government owned it. They were able to make modifications that Colt was responsible for. Colt would receive royalties to it. And part of that was anything that was done with that rifle, once the 1968 licensing agreement was paid up, was authorized and done by Colt. So when the M16A2 was developed, that was a joint operation between the U.S. government and the Marine Corps. That fell under the 1968 licensing agreement because there was U.S. government money used to fund the M16A2, the M16A4 programs. However, the M4 program was not funded by the U.S. government. That was actually funded by Colt. This is one of the things that separated the M4 family from the M16. Most people will look at the guys and say they're all the M16 family. Well, technically they're all M16 family. I guess in my opinion, I would have to agree with that. However, the M4 carbine had a significant number of changes to it that was totally outside of the 1968 licensing agreement, which is where you get M4 versus M16. So starting back in 1985, you had the adoption of the M16A2 and the M855 ball cartridge. There was a requirement set forth by the Marine Corps for a carbine. And of course that carbine had to utilize the new M855 ball ammunition. This initial request did not last very long. It was defunded and it didn't go further. And Colt actually started moving forward with the development of a new carbine. They looked at the M16A1 carbine and they saw the modifications that were made on the M16A2, and they could certainly pair them together with several of the changes. For instance, the original XM4 carbine basically was what we refer to as the M16A2 carbine. It had the M16A2 carrying handle. It did have the extended feed ramps, which we're going to go over in a little bit. It had the double heat shield handguards, which were utilized to protect the shooter's hand. It utilized a 1 7-inch twist barrel with also the step cut to allow the adaptation of the M203 grenade launcher. The early rifles also were fully automatic. There was no 3-shot burst. They utilized the second generation polymer stock. These guns were visually seen actually in, I'm sure you may have seen the movie Black Hawk Down. What those guys were using were XM4 carbines or M16A2 carbines. The term XM4 didn't come into play really until the U.S. government started looking at it and started testing it. Oddly enough, the M16A2 carbine, according to Colt, was very similar to the XM4. However, Colt had what they called the M4A1 also, which is different from the M4A1 government model. The M4A1 actually utilized the Mill Standard 1913 rail, which is something else that we're going to discuss. So when you hear Colt's definition of M16A2, XM4, M4, M4A1, you need to be able to separate that from the actual U.S. government rifles. The M4, M4A1 were the finalized TDP adopted rifles, for the U.S. government. So first generation M4 carbine, M16A2 carbine, basically. There were some of the changes made, such as the feed ramps. You did have the new handguards. You did have the new barrel profile. It was never finalized for U.S. government use. It was a commercial off-the-shelf rifle. Now we're going to move forward to the XM4 program. Colt, in the meantime, the government was on and off looking for a replacement carbine. The government ended up doing, they wanted to look for a replacement for the M1 carbine, the fully automatic M2 carbine, the M3 grease gun, and M4 was the next in line. That's where the actual term M4 comes from, is the next in line for a personal defense weapon. Again, as the rifle was conceived, it wasn't conceived as a frontline battle rifle. It was considered for the same purpose the M1 carbine or the M2 carbine were. Not a full-size battle rifle, but more firepower than an actual pistol would give. What we're going to talk about now is the M4 carbine, what changes were made to it, which actually got it outside of the U.S. government's 1968 licensing agreement. The rifle that we're looking at here is actually a Colt LE6920. The LE6920 was introduced in 1998, well after the adoption of the M4 carbine in 1995. It has all of the enhancements of the U.S. government M4 carbine. Most of the parts are the exact same. The only major difference is the fire control group. This is a semi-automatic only, and also the barrel length. This is a 16-inch barrel versus a 14.5-inch barrel. Other than that, this gun is pretty much identical. We're actually going to start from the butt of the rifle, and we're going to move forward. First of all, we're going to look at the stock. This is the actual U.S. government issue stock that's current. Prior to the adoption of the M4, we had the original M16A2 stock, which was actually polymer. It was a smooth polymer versus the aluminum stocks that were on the original GAW rifles and XM177s. This would be considered the third generation stock. If you look at the first generation, it was actually an aluminum stock that was put on the GAWs and the XM177s. Then come time for the M16A2s, they actually had the similar stock, but it was made of polymer. It was all smooth. And you will actually find M4 carbines that were delivered to the U.S. government with that. This stock here was actually created at Picatinny, is a much better and more durable stock, more durable material. So this is what is currently on the M4 carbine that's being issued. Special Operations Forces, the Navy have adopted other types of stocks, such as the LMT SOT-mod stock. But the actual TDP rifles, where they're purchased and delivered to Afghanistan, is going to be the actual third generation stock. The receiver extension itself, the biggest change that has had since the M16A2 moving forward. The original GAW rifles and XM177s utilized a two-position stock. So you had fully closed and fully out. The receiver extension itself was actually changed to include four positions. And the main reason for that was the use of body armor had massively increased. Vietnam era, you basically had flak jackets that were not really that thick compared to modern body armor. And what this did was it enabled you to be able to adjust to the thickness of the body armor that the individual soldier had, so they could get a good cheek weld on here to be able to use their optics. Was the actual purpose for that. The next change was the actual barrel nut itself. Most of the M16A2 carbines, and of course the early GAWs and M16A1 carbines, utilized the original receiver extension nut, which was adjusted by a spanner wrench. You had basically a hole, and you had a spanner wrench with a little tit hanging down that you would hook into the receiver extension nut, and you would rotate. That was not a very effective way of doing it because those little tits on the wrench would break right off. So during the M4 development, they reached a new design. The new design actually had 4 locking grooves where a wrench would get in there. It would be much easier to stake. During the development process, a new buffer was created for the M4 as well. This actually worked on the same issue that the M4 feed ramps did as well. In the end, you either needed one or the other. You didn't need both, the extended feed ramps and the buffer. Or we're going to explain the whole concept behind this. But I will tell you that the feeding issues that were caused by the actually M855 round. If we take a look at the actual M855 round versus the M193, looking at the two cartridges here, we have the M193 ball on the side here. This side here is the M855 ball. If you actually look at the shape of the projectile, you'll see that the ogive on the M855 is much sharper than that of the M193. The M193 and the GAWs and the XM177s did not have any issue because of the shape of the projectile with it being presented into the chamber along with the cyclic rate. They found with the M855 ball in the carbines, due to the higher rate of fire, that the actual nose of the projectile could actually get caught or or jam, striking the actual barrel extension itself or the receiver itself. They needed to slow down that closing stroke to allow for the cartridge to be able to fully present itself to go into the chamber. The feeding issues were dealt with Colt in 2 different ways. First was with the development of a new buffer. This is referred to as the H2 buffer. And the H2 buffer has 2 steel weights and 1 tungsten. The actual tungsten weight is one of these is the same weight as 2 of these. What that did was it slowed down the closing stroke on the buffer, on the belt carrier itself. What that did was it allowed enough time for the M855 round to fully present itself, so it would go straight into the chamber. The second way it was approached was actually making an extended feed ramp, which this cured the problem as well. So basically, the M4 carbine, you actually will see these on all of the